Okay, so for the physiological part, my performer, I want to speak about the muscles involved, which are the bicep femoris, which contracts concentrically as the agonist when the knee flexes. Knee's hinge joint, so this is happening when she lunges before a movement, so the aerial cartwheel when she lunges into it, and then after when she controls the landing. The rectus femoris is used, which is in the quadriceps, and that again contracts concentrically as the agonist when the knee extends. This happens when she pushes off a leg and it becomes straight, and then when her legs are in the air, they need to be straight as well. So the antagonistic muscle pairs work better together and have better coordination after a warm-up because the coordination is improved. So a warm-up will provide like a gradual increase in blood flow, so cardiac output, due to the vascular shunt mechanism, which is the process of redistributing cardiac output, so blood from the heart basically. This is done by vasoconstriction of organ arterioles, precapillary sphincters, and so from doing that it will decrease blood flow to the organs as they don't need it as much and the muscles do. The muscles get an increased blood flow by vasodilation of arterioles and precapillary sphincters. Also, warm-up will increase body temperature, which increases blood viscosity, so that will reduce the resistance to blood flow. So improved blood flow to working muscles, and it increases the dissociation of oxygen from hemoglobin, so more oxygen can be used by mitochondria in muscle cells for cellular respiration. Warm-up will also increase oblo, which is the onset blood lactate accumulation. So it's the point at which lactate accumulation exceeds the lactate removed, so it can lead to muscle fatigue. And this is due to anaerobic work without a warm-up. Cool-downs can keep metabolic activity elevated, which decreases heart rate and respiration rate gradually. This maintains vasodilation of muscle arterioles, precapillary sphincters, and keeps capillaries dilated, so muscles can be flushed with oxygen, and oxygen breaks down lactic acid. As lactic acid is broken down, it gets broken down into pyruvate and then converted into glucose, which can be used as a fuel once again in the aerobic glycolysis in that. The ATPC system is used at first, which is an anaerobic system, as oxygen is not present. Fuel for this ATP and PC in the muscle cell sarcoplasm. It's a coupled reaction, and the enzymes are ATPase and creatine kinase. Coupled reaction because two reactions take place, which is PC, so phosphocreatine, plus a phosphate plus creatine plus energy, which is an exothermic reaction, as energy enters the environment and exits the body. And then energy plus ADP plus an inorganic phosphate makes ATP, which is the body's only readily available source of energy to use. That's an endothermic reaction, as the energy is used up. So this will make a total of 1 ATP, which will last 2 to 10 seconds, as the first 2 seconds of this is already occupied by the ATP that you've already stored, as you've already got one stored, which will last up to roughly 2 seconds. Advantages of this is that it doesn't require oxygen. PC is already stored in the muscle cell, so it's readily available, and on the other hand, there's only small amounts of ATP and PC stored, so you've got to make it and resynthesize it all the time.